All right, we're going to talk about polygons, okay? So first of all, the requirements of a polygon, okay? There's a couple requirements that it has to have. It has to have straight sides, so it can't be curved. So like a circle is not a polygon, okay? It has to be closed, which means all the sides connect to each other, so it's not an open shape, okay? So that means if it's going to be straight sides and closed, that means the minimum number of sides it has is 3, okay? So the smallest type of polygon is a triangle, so minimum of 3 sides, okay? And those sides also can't overlap. Sides can't overlap. So each type of polygon has its own name depending on how many sides it has, okay? So I just mentioned the first one, which has 3 sides, and those are called triangles, obviously. Triangle, 3 angles, okay? If it has 4 sides, you would call it either a quadrilateral, so 4 sides, or a quadrangle, 4 angles. We'll mostly call it quadrilateral, so I'm just going to write that one up there, okay? Then you get into these with the agon. So 5, we got pentagon. 6, we got hexagon. 7, we got heptagon. 8, we got octagon. 9, we got nonagon. 10, we got decagon. Okay, it keeps going and going and going. Eventually, it gets to a point where they don't have fancy prefixes. They'll just say like 37agon, right? So it just means it has 37 sides, okay? But the prefix is representative of how many sides it has, okay? Make sure you definitely know, I mean, you should know all of these, or at least be familiar with them or be able to figure out which is which, okay? So make sure you copy this down for requirements for a polygon and the names of the different sided types of polygons. So all of these are types of polygons. All right, so let's look at quadrilaterals. We're going to look at this fancy quadrilateral flowchart I made. Here we go. So quadrilaterals themselves get pretty specific, kind of like triangles. Remember how on the triangle one, we had acute and obtuse and all that. Same with quadrilateral. So just a general quadrilateral just means it has 4 sides, okay? And then you might have some parallel sides thrown there. So if you have one set of parallel sides and only one set, this is called a trapezoid. Okay, so it looks like this. You have one set. The other sides aren't parallel to each other. Might look like that. You might have a right angle trapezoid like that. Okay, as long as one set is parallel to each other, it's a trapezoid. If both sets of opposite sides are parallel, then it's called a parallelogram. Makes sense, right? So both the top and bottom are parallel, as well as the left and the right are also parallel. All right, within parallelogram, there's even more specifics, okay? You can have a parallelogram where there's all right angles, and that would be called a rectangle. You can have a parallelogram where all sides are congruent, and that would be called a rhombus. Or you can have a parallelogram where both of these things are true, and that's called a square. Let me scroll down there a little to a square. Okay, so all sides and angles are congruent. Okay, so this is a little bit like a family tree if you look at it, okay, because they're all related to each other, but it's just getting more and more specific, okay, because a square is technically a rectangle, a rhombus, parallelogram, and a quadrilateral because it fits all those definitions, right? A square has all 90-degree angles. A square has all congruent sides. A square has parallel opposite sides, and obviously a square is a 4-sided polygon. So a square is all of those, but most specifically, it would be called a square. A rectangle, we're looking at a rectangle, is obviously a parallelogram because its opposite sides are parallel. It's obviously a quadrilateral because it has 4 sides, but it's not a rhombus, okay, because all sides are not congruent, right? These sides are longer than the other sides. And it's not a square because, again, all sides are not congruent. Okay, so you can do this for all of these. So it's important to know the exact definition so you can figure out what's included and what's not, right? A parallelogram is not necessarily a square unless all the sides and angles are congruent. A parallelogram is definitely not a trapezoid, right? Because a parallelogram has 2 sets of parallel sides, not just 1 set. Okay, so make sure you copy this down, okay? And familiarize yourself with it, because There loves being the questions of, is a square a rhombus? Yes. But is a parallelogram a rectangle? No, not necessarily, right? Is a quadrilateral a trapezoid? No, not necessarily, okay? So it's important to know all the different definitions so you can answer questions like that. Feel free to pause this if you need more time to copy this chart down. That just says quadrilateral up there. Sorry, it doesn't all fit on one page. And ignore the area formulas for now. We'll get to those eventually, okay? This is important actually right here. This 360 degrees, all quadrilaterals, their angles add up to 360. Just like triangles add up to 180, quadrilaterals add up to 360. So we're about to talk about that a little bit more. All right, so if we look at this, so there's this thing called regular and irregular, okay? So if it's a regular shape, that means all the sides are the same. You're used to seeing regular shapes like pentagons and things. They'll normally show you the regular version of them like that, where all these sides are the same. An irregular pentagon would look something like that, right? It still has 5 sides, but they're not the same, okay? So looking at this shape, this is clearly a quadrilateral, right? Is it regular? No. Okay, not all the sides are the same as each other, okay? So we would call this a quadrilateral. And then you could also more specifically call this a parallelogram, okay? Because the opposite sides are parallel to each other. Now, it's not a rectangle. It's not a rhombus because it doesn't have the right angles or equal sides. So most specifically, parallelogram. This one, is it regular? No. And we could call this one also a quadrilateral. It has 4 sides. More specifically, I would call it a trapezoid, okay? Because it has that opposite set of sides is parallel, but only one set of parallel, not 2 sets. All right, again, not regular. And it has 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. And we would simply call it that, an octagon. No way to get more specific for that. All right, this one, we finally have our first regular shape. So it is regular because all 4 sides are congruent to each other and all 4 angles are the same. They're all these nice right angles. So this one has lots of names. We can call it quadrilateral. We can call it a parallelogram. We can call it a rectangle because it has those 4 equal sides. Sorry, 4 equal angles. We can call it a rhombus because of the 4 equal sides. But most specifically, I'm sure you all know, it is a square. Okay, because it has all of those. So a square is lots of different things because it has so many specific requirements of it. So a square is the only regular quadrilateral, right, where it has the 4 equal sides and the 4 equal angles. All right, here's another regular shape, not a quadrilateral this time, but it is regular. And it has 1, 2, 3, 4, 5, 6 equal sides, so that's a hexagon. And if you want to be super specific, you would call it a regular hexagon. But hexagon's just fine too. There's a regular hexagon. Okay. All right, so like I mentioned before, the angles add up to 360, which makes it pretty easy to find a missing angle like this one, okay? All you have to do is add up your missing angle, or add up the angles they give you, okay? And then the 4th one is going to add up to have it equal 360 altogether, okay? So if I add this all up, I get 270 plus x equals 360. This is clearly not drawn to scale because we end up getting 90. So that 4th angle there is 90 degrees, okay? Now keep in mind, some of you kind of freak out when that happens and you're like, that doesn't make any sense, that's clearly not a 90-degree angle. But it's okay, these are just, it's more testing your knowledge of the 4 angles add up to 360 and less actually measuring that specific angle, okay? It's not drawn to scale. All right, so let's try another one. So go ahead and pause it, try this one on your own, and then hit play to check your work. All right, so this one we got 77 plus 103 plus 81 plus our unknown, we'll call it y this time, equals 360. Okay, So that's 261 plus y equals 360. So when I take away 261, we get 99 degrees for my missing angle. So this one's 99 degrees. All right, let's do one more. So this one's throwing in some algebra. Go ahead and pause it, try this one on your own, and hit play to check your work. Okay, so we're going to combine all this to equal 360. So we got 3x, that's 6, 11, 15. Okay, 15x plus the 10 equals 360. Take away the 10, get 350. All right, so x ends up equaling, not going to be even, is it? It goes to 350. 15 goes in there twice with 50 left over. So do 3, that's 45. 50 left over, so it's 23.3 repeating for x. Doesn't make it super enjoyable to figure out what these are, but you would end up doing 3 times x. So let's just round it off to 23 to make life a little bit easier. So if I do 3 times that, I get 69. So that would actually probably be just about 70. Okay, so this is also 70. 5 times that, we'll say, is about 115, although it would probably round more to 116. 4 times that, we got 80, 92, plus that is 102. And there you go.